Hi everyone. Okay, so I want to do a table example in this video, and then I'll do a graph example as well, just so you kind of have all your bases hit. But if you're feeling pretty comfortable with what's going on in this section, feel free to just give it a try. Like I said, there's not really much new content in this section. Most of the work here is the same kind of work you've been doing. Or go ahead and pause this video and work through, and then come back and use the video to double check yourself. But it's absolutely possible that you don't feel like you have to watch all of this to get going on this homework. Okay, so table example. I have a table that defines two functions for me, f of x and g of x. So first row is my inputs, my x's, and then second row is my outputs or values of f, and third row is the values of g. Okay, so we're supposed to evaluate each of the following. So f minus g of 3, and you don't have to write this every time, but what I'm thinking is that I would get that by finding f of 3 and subtracting g of 3. So f of 3, let's see, here's x equals 3. F of 3 is 1, g of 3 is 2, which means f minus g of 3 is 1. And here's something I can emphasize here that I didn't really in the last one. So I did talk about the fact that f minus g is the name of a new function. What we could emphasize here is that the information we got is that f minus g of 3 is 1, which tells me that the graph of f minus g goes through the point 3, 1. The 1 and the 2 I got from f and g. I needed those to find the value of f minus g, but those are not values of f minus g. Those are values of the function separately. So the value of function f minus g when x is 3 would be 1. F times g of 6, so I would need f of 6 times g of 6. Again, okay with me if you skip this writing them separately step. I just want to be really clear that that's what happens. So f of 6 is 1. Oh, what am I reading? F of 6 is 7. I'm reading the one that I put in big circles on my graph. Might have been a bad idea. Here, we'll erase them. F of 6. F of 6 is 7. G of 6 is 3. So I have 7 times 3, which is 21. Again, the answer to that question is just 21. But what that does tell me is that the point 6 comma 21 is on the graph of FG. All right, G over F of 1 is going to be G of 1 over F of 1. 1. Okay, so now, let me erase again so I don't confuse myself. 1. G of 1 is 4. F of 1 is 6. So 4/6 is my answer. I'm going to reduce that. Cancel a 2 out of the top and the bottom, and I get 2/3. Okay. So this is back to that point I was trying to make last time. F of 3 minus f of 2. Okay, so f of 3 is 1. F of 2 is 3. So I get 1 minus 3, which is negative 2. This is not the same as f of 3 minus 2. To find f of 3 minus 2, you should just do the subtraction. So always be thinking order of operations. Here, work from your parentheses out. So I'd first say, okay, what am I supposed to plug into f? I'm supposed to plug in 3 minus 2, which is really just 1. So now I go back up to my table and I say, okay, what is f of 1? It's 6. Notice that these are not equal. And what I'm really trying to push here is that f functions don't distribute. F of 3 minus f of 2 is not, we're going to put a really big no here. Mad, sad, mad face. I don't know what he is. F of 3 minus f of 2. Do not distribute. When I'm doing this up above, it's not distributing. It's using the definition of subtracting functions. F minus g is the function that I get by taking f of x minus g of x. So very, very careful. It's just kind of an unfortunate notation thing that makes that super tempting. Okay, and last but not least here, f of 3 minus f of 1 over 2. F of 3, what did I say that was, is 1. F of 1, I got in the last part, is 6, and I divide by 2, so I have negative 5 halves. And that's great, and I'm done. What I would want to point out there is what we just did is calculate a slope or an average rate of change of function f. Okay, I have one more part here, and I don't think I actually asked you to do this on your homework, but I think it's a really good exercise just to kind of emphasize what's happening. So I have a table that represents f and a table that represents g, and now I want to build a table that represents g minus f. And in this case, it's actually okay for me to just tack it right on here, so I'm going to do that out of laziness sake, because what can I plug into G minus f, the same things that can get plugged into both f and g. So as long as it can get plugged into both, it can get plugged into the difference or the sum or the product. Quotient's a little different, but for those other three, that's great. So if I plug 1 into g minus f, g of, can I do this without tongue-tying myself? Okay, so g minus f of 1 is going to be g of 1, which is 4, minus f of 1, which is 6. So I'm going to get negative 2. G minus f of 2 is going to be g of 2, which is 0, minus f of 2, which is 3, so negative 3. Let me zoom back in here. My writing's getting kind of scrunched. Okay. A little bit better. I think I just did all that erasing for not very much. Okay, so g minus f of 3 is going to be g of 3 minus f of 3. 2 minus 1 is 1. G minus f of 4 is going to be g of 4 minus f of 4. 5 minus 4, also 1. G minus f of 5 is going to be g of 5 minus f of 5. Negative 2 minus 0, still negative 2. Almost done. G minus f of 6 is going to be g of 6 minus f of 6. 3 minus 7 is negative 4. And then last but not least, g minus f of 7 is going to be g of 7 minus f of 7. 1 minus 6 is negative 5. So the combination of the input row and this, values of g minus f, define the function g minus f. So it has the inputs that are the same as f and g, since those two match up perfectly in this problem, but it has its own new set of outputs. Okay, let me make sure I didn't sneak anything else exciting. I don't think so. All right, thanks for watching the table example.